The electric charges which we are dealing with have certain properties. One of them is total charge on an isolated system is conserved. That means the total charge, positive and negatives, on a system is always constant. This is known as law of conservation of charge. Second is quantization of charge. That means total charge on a system is always some multiple of charge on the electron. Here in this case we have Q is equal to plus minus NE. N is an integral number 1, 2, 3. There are two processes in physics where we verify this law of quantization of charge. One is called pair production. Here in this case, a gamma ray photon when comes close to nucleus of an atom breaks up into three particles, electron, positron, plus a new particle known as antineutrino. This is called pair production. These particles, they are just pairs with difference only in the sign of charge. One is negative and positive, otherwise charge, quantity of charge and mass, they are equal. Second process is annihilation of matter. In this case, if electron and positron, they are brought close to each other, then these two particles, they destroy themselves and we get the formation of two gamma ray photon. Get the formation of two gamma ray photons. These two gamma rays, they are going in the opposite directions. So this is called annihilation of matter. Another property of electric charge is additive property. Additive property. Additive. That means they can be added just like scalar quantities. If we have different bodies, one is having Q1, second is having Q2 charge, Q3, different bodies, then total charge can be obtained by just adding like scalar quantities, like scalar. This is called law of additive property. Then another is the charge on a body is independent of the motion of the particles. Electric charge is independent. Of the motion of particles. Particles carrying charge. For example, in the atom, electrons are moving in orbits. These electrons, they have fixed charge. Their charge, quantity of charge doesn't change with motion. It remains same. And velocity of the particle has no effect on the charge on the particle. So this is the fact that electric charge is independent of the motion of the particle carrying charge. After taking these properties and Coulomb's law, we can proceed with Coulomb's law in vector form. Coulomb's law in vector form. So we can write force between two charges in vector form as one by 4 pi epsilon Q1 Q2 R square R cap. So this is Q1, this is Q2, this is R. So R vector from Q1 to Q2. If we want to write Coulomb's law in position vector, then we can proceed as follows. We have three axes. Then we can join. This is your vector R1, your vector R2. Then R is equal to R2 minus R1. Vector R is equal to R2 minus R1. So we can write Coulomb's law in terms of position vectors as 1 by 4 pi epsilon 0 Q1 Q2. For R we can write this square then we can write R unit vector as R2 unit vector, R1 unit vector, or it can be written in this form Q1 Q2 4 pi epsilon 0 R2 R1 cube R2 minus R1. Instead of unit vector, you write full vector. So this is Coulomb's law in terms of position vectors. So if you have a large number of, you can say, charges and you want to write in vector form or in position vectors for large number of charges, you can write force on the ith particle as Q1 Q2, sorry, you can say write as Qi 4 pi epsilon 0 sigma j going from 1 to n Qj r j minus ri cube rj minus ri. So we can write in this, or if there are large number of charges, j going from 1 to n charges, and on the ith charge, this is the force according to Coulomb's law. Now we want to see what is electric field. The space around a charged body where its influence can be felt is known as electric field. Electric field can be measured. The strength of the electric field can be measured by a quantity known as E. Electric field. It is given by force acting on the charge. If force F is acting on the charge, then electric field at that point is F upon Q. This Q is called test charge. This force is due to source charge, and this force is acting on a test charge Q. So this test charge should have a quantity value very small, because if it is large value, then it will influence the force or electric field due to this charge. We are interested to find out what is the electric field due to source charge. So this Q should be as small as possible. Should be small as far as possible. Small. So this is E is equal to F upon Q. So if we have two charges Q1, Q2, and force is represented by this, then we can find our electric field by this formula. This electric field will be given by F upon, if Q1 is source charge, so Q2 upon 4 pi epsilon 0 r square r cap. This is the value of electric field. After this, we can have electric field due to various distribution of charge. Various distribution of charge. We can have linear distribution A to B, and linear distribution of charge is represented by a quantity known as linear charge density. Linear charge density. And we represent it by lambda r. Lambda. In this case, if we are interested to find out the electric field due to this linear distribution charge A to B, take a small element here, dl, and take the middle point here. You can say that some point O, we have these three axes, OX, OY, OZ. Then this is your R. Then we can find out if this is the point charge Q0. You are interested to find out the electric field at this point. This is R, this is R0. This vector will be R0 minus R. Then we can write force given by charge Q0. We are interested into this small element, lambda dl. Linear charge density, charge upon length. Charge of length is linear charge density. So for length dl, the charge will be lambda dl, 4 pi epsilon 0 into we have R0 minus R cube R0 R vector. This is charge on this Q0 due to this small element lambda L. You can call the dF, total force due to the hole. We can integrate. This will be equal to Q0 lambda dl 4 pi epsilon 0 R0 minus R cube R0 minus R. Now these quantities can be taken outside and you can write Q0 lambda 4 pi epsilon 0 integral A to B dl R0 minus R0 minus R cube. So in this way we can find electric field force, then you can find electric field. E will be equal to F upon Q0 lambda 4 pi epsilon 0 A to B dl R0 minus R0 minus R cube. So in this way, for linear distribution of charge, we can find electric field by first finding force and then electric field force upon Q0. Now second distribution of charge is surface distribution of charge.